Today we would like to introduce Signation, a sign language interpretation system applied to the automation of environments of people with hearing and communication disabilities. Come here.
We use the controller RM4 Pro, a Raspberry Pi 3 to control all the action, and also we need a computer with a webcam to control the air and projector.
First, we will perform the download of Apache Spark and Kafka with Scala version 2.12. Once the load we process to onset, go to Kafka configuration and we will open the file service properties, modify the listeners with local and the directories and logs. Then go to the zookeeper configuration and modify the directory. Later, go to the Spark configuration and the files we have points in place. We will delete and it remains with your specific file type. In the file log for the 2 point properties, we will have some variables that have been assigned to them. They will be changed to Word for security reasons. In code, the first file is manos.py for the datasheet of system. In this we will export the libraries. To use is in session CV2. That will be the one that allows to open the camera. We have name and others. In this point we will have to make change because we'll have a folder for validation and another one for training. Validation will have 600 photos and training 2400. We assign a counter and with CV2 we will read the computer camera. We proceed to create an add object. Here we will have 4 points, 1 point, assign false so that we do not have detection all the time. 2. Maximum number of count, 3 and 4. Truth detection and tracking. And we will draw 21 points on detected hand. We assign the reading to variables and proceeded to perform colorimetry so that the sign can be better observed. The imaging is processed and stored with a vector. Once the hand is recognized, we look for the hand and we will have 5 specific points to identify each finger and each image is storage. The final validation will be that when you receive the requisite number of the photos, the training is completed. For the training code, we import the TensorFlow and Keras libraries to use, and we will take the data from the training and validation folders. We will perform validation 3000 times because it's the total amount of features, and we adduce the neural network to get a more accurate solution. We process the imaging, include viewable tilt angles, validate and classify them. In this section, we create the neuronal network with 3 layers. We assign 256 neurons, but when turned off, half of them to avoid saturating the network is important. To optimize the model, we use Adam with accuracy metric. Finally, we enter all the parameters and save the model and image weights. In the string handler, you have two files, where in build we add the Scala version and the Spark dependence. With that and string handler point and Scala, the libraries are imported. Initiality and process to read Kafka and topic created to send the frame. The data writing is performed and the process is finished. Code API is the most important. In this, we have imported like libraries, models, and weights. Of the images are loaded by flags. We start the API locally, and once enabled, we load the camera. We will have the connection with the database MongoDB. By means of foundation, we generate the streaming and we say that is recognize the image with format GPG. It is saved in a local way and now part of the code of train of hands we visualize again in this point for the recognition of the hand with its respective characters. Say in a variable that enter validation to verify the type of sign is being made. Once it is identified, a message is displayed and added to the database. Among the most relevant aspect is the connection with Kafka. Through the producer is the API. The information is sent to interpreter topic. Finally, is load the index of URL. The index will be based on bootstrap. Is a template where we will add the name of the project, call to the camera, and two buttons reference to their activity. The Kafka comments will allow to start the servers. We have Zookeeper and Kafka. Start for both Windows and Linux. Topic creation in our case called interpreter. In addition, there are commands to list, delete, and test. Through producer and consumer is for test. By means of Spark Submit, the application are started in a cluster and we visualize how it stay waiting for the data to be entered. We proceed by initialize the Kafka on Spark. We first open CMD. In the indication of Kafka, use CMD for Kafka and one CMD in the folder this interpret. The command for Zookeeper and the command for
a server. The topic interpreter is created. When we launch Spark Summit and now we will go to execute the API code from PyCharm. The Spark Summit sphere the API is already working. In MongoDB, we observe the project create. In this case, we will open Interpreter. Here, we observe the data sent. We can observe metrics from a week ago on the signal received, and in collections are the objects entered with their ID and value. Database, collections, values.
The user coming in the local server across the web, it will appear the interface. The user must make the signal and click in the button, and finally the action has been executed.